What is the general shape of the sine graph? Sine is a sinusoidal function that repeats over time. It's a periodic function. It starts from the origin, and if you have the positive sine function, it's going to go up, and then it's going to repeat like a wave. So I'm just going to draw one cycle. The amplitude is the number in front of sine, which is a 1. So it's going to vary from 1 to -1. Negative sine is very similar. However, it's going to start from the origin, but instead of going up, it's going to go down. So as you can see, it reflects over the x-axis. Now this function continues forever in both directions. Therefore, the domain for any sine function is -infinity to infinity. However, the range has limitations. As you can see, the lowest y value is -1, and the highest is 1, if the amplitude is 1. Sometimes that number can change. But for this particular function, the range is -1 to 1. Now what about the graph? Y is equal to positive cosine x. Cosine starts at the top, and then it forms a sine wave. It repeats. But if you just want to draw only one cycle, it looks like this. Negative cosine starts below the x-axis, and then it goes up. The amplitude varies from, the amplitude is 1 in this case, which means the y values vary from -1 to 1. So the range is the same as the sine function. And because it's a periodic function that goes forever, the domain is all over numbers, -infinity to infinity. And there's one more trig function I'm going to go over in this video, and that is the tangent function. Tangent has a vertical asymptote at -π/2 and at π/2. And it's an increasing function. Now this shape repeats across each vertical asymptote. The next vertical asymptote is at 3π/2. And it's going to have the same shape. So x could be anything except the vertical asymptotes. So x cannot be n/π/2 for this exact function, where n is a number such as ±1, ±2, ±3, and it goes on forever. Actually not 2. It's only odd numbers. So ±1, ±3, ±5, and then the pattern repeats. The range of a tangent function is -infinity to infinity. To write the domain is quite difficult because this is going to go on forever. So x could be anything except these values.